Welcome, dear students. Assalamu alaikum wa rahmatullahi wa barakatuh. We start today the seventh lecture in the 7th week in the course Physiology 2, entitled Physiology of Pain 1. Firstly, we identify the ILOs to understand the definition of pain, to understand the benefits of pain sensation, to list the components of pain sensation. Starting first with the definition of pain. What is the pain? Pain is an unpleasant or emotional experience associated with or without actual tissue damage. Pain, unpleasant sensation. Unpleasant sensation caused by tissue damage and is produced by real or potential injury to the body. This is the cause of pain, potential injury or the real injury of the body. The pain sensation is described in many ways, such as sharp, pricking, electric, dull aching, shooting, cutting, stabbing. All these forms are the different forms of the pain sensation. Maybe sharp pain as in skin laceration or skin injury, and pricking pain also as a pin incision or stimulation of the skin, and electric by electric current, dull aching pain as a deep pain, shooting pain as a gun shooting, as a cutting pain by stabbing pain, or etc. Sometimes it induces crying and fainting. Crying and fainting. Pain produced by fire is expressed as a burning sensation, as when touch a very hot object or a fire, expressed as a burning sensation. As a burn, pain produced by severe sustained contraction of skeletal muscle is expressed as cramps. Cramps, which occur in football players, occur by sustained, maintained contraction of skeletal muscle. And then what is the difference between nociception and nociceptors? Nociception is the process of pain sensation, a process through which the peripheral pain receptor transmit information about current or potential tissue damage centrally as a pain. When the pain are transmitted in the peripheral nerve, is called and is received by the cerebral cortex and identified as a pain, is called nociception. And the nociceptor is the receptor of pain, receptor in end organs that detect biochemical change associated with current or potential tissue damage. When the tissue is damaged, it causes a biochemical change around the receptors, and then the receptor is stimulated by these biochemical changes and transmit the sensation of pain in the peripheral nerve. This is a nociceptor. There is a difference between nociception and nociceptors. Other important definition of pain, there is allodynia, hyperalgesia, and hypoalgesia. When we see this figure, we notice that this is on the horizontal plane, this is the stimulus intensity, and on the vertical plane this is a pain intensity. Stimulus, and this is a pain. When the stimulus reaches the threshold at this point, we just feeling the pain, and the pain intensity is very low. And when the stimulus intensity is increased, the pain also is increased. This is a normal pain curve. normal pain curve. When the stimulus intensity increased, the pain intensity is increased. And what is the allodynia? Allodynia means pain due to stimulus that doesn't normally provoke pain. We can't reach the stimulus intensity or the threshold of pain. We just feeling pain. This is called allodynia. Allodynia, pain due to stimulus, normally doesn't provoke pain. As example, when we complain of burning on the skin, and when touch the skin, we sense the pain. Touching the skin in normal condition doesn't provoke the pain, but when the skin is burned, it provoke pain. This is called allodynia. What is the hyperalgesia? Hyperalgesia increased pain from a stimulus that normally provoke pain to the normal. Hyperalgesia increased pain from the stimulus that normally provoke the pain. And this is a hyperalgesia. This is a hyperalgesia. Normally we felt the pain at this level, but when the skin is hyperalgesic, we sense the pain at this point, means that the pain intensity is increased than normal. Hypoalgesia, diminished pain in response to normally painful stimulus. Hypoalgesia, there is no curve for hypoalgesia, but we can draw curve here for the hypoalgesia. That is the hypoalgesia, diminished pain in response to normal painful stimulus, but we can receive pain as normal. There is a diminished pain sensation. Okay, this is a difference between hyper and hypoalgesia. It gave warning signals about existence of a problem or threats. The pain announces us about there is a threat or problem. It creates awareness of pain. It prevents further damage by causing a reflex withdrawal of the body from the source of injury. When we exposed to the fire or a hot object, we soon reflexed withdrawal away from this noxious stimulus, and in this cases the pain have a benefit that we causing a reflex withdrawal from the source of the injury. It forces a person to rest or minimize activities that enable the rapid healing of injured part, as in case of bone fracture. When my bone or our bone is fractured, we rest the limb that fractured and minimize the activity of this limb, enabling the rapid healing of injured part or fractured part. It urges the person to take required treatment to prevent major damage. When we felt the pain, we seek the treatment. To prevent major damage. What is the process of pain physiology? Process of pain physiology, 4 parts: transduction and transmission and perception and modulation, and we will discuss any of this in details. We firstly begin with transduction. What is the transduction? Pain stimuli are converted to electrical energy. Okay? Pain stimulation converted from chemical changes that occur around the receptors to electrical energy that transducted in the peripheral nerve. This electrical energy is known as transduction. Transduction meaning transform of chemical change that occur around the receptors to electrical change that is conducted in the peripheral nerve. This stimulus sends an impulses across the peripheral nerve fiber. This is the transduction. Transmission is the transmission of signals in the peripheral nerve. We have two major different peripheral nerve. The first one is A delta fiber and second one is a C fiber. A delta fiber different from the C fiber that A delta fiber are myelinated fiber and have large diameter, and C fiber are unmyelinated fibers and have small diameters. A delta fiber send sharp, localized and distinct sensation as a fast pain. A delta fiber transmit fast pain as sharp, localized and distinct sensation. But C fiber relay impulses that are poorly localized. When the pain is diffuse or burning or persistent pain stimuli travel in spinothalamic tract, and we will discuss the difference between slow and fast pain in details in the next slide, and we will discuss the difference between A delta and C fiber. Perception is awareness of pain. Somatosensory cortex identifies the location and intensity of pain. Awareness of pain. What is the modulation, or what is the kind of the pain? Just we perceive it in the cerebral cortex. Is a dull pain, or sharp pain, or breaking pain, or diffuse pain? This is a perception. What is the modulation? Modulation is the inhibitory neurotransmitter like endogenous opioid, as enkephalin and endorphin. This is an endogenous substance which cause a killing of the pain, work to hinder pain sensation, and this inhibition of pain impulses is known as a modulation. Modulation means inhibitory neurotransmitter like endogenous opioid is hinder the pain sensation. What is the composition of the pain, or component of the pain? We have two components of the pain. We have fast pain and we have slow pain. Fast pain is the first sensation whenever pain stimulus is applied. When we applied stimulus by stab wound or by a sharp knife, firstly we sense the localized pain. Then the pain is converted into diffuse pain. Then the fast pain is the first sensation whenever pain stimulus is applied. It is experienced as bright, sharp, localized pain. Bright, sharp, and localized pain. The fast pain followed by slow pain, which is experienced as a dull, diffuse, unpleasant pain. Sharp in the fast pain, and dull in the slow pain. Localized in the fast pain and diffuse in slow pain, and unpleasant pain. Firstly, we in every kind of pain, we firstly sense fast pain as a bright, sharp, localized, and then the fast pain is converted to slow pain, and we will sense this slow pain as a dull, diffuse, unpleasant pain. Fast pain detected by myelinated A fiber, as we discussed before. Perception occur rapidly, and stimulus cause sharp, bright, localized pain, not felt in deeper tissues, but felt in skin only. In contrast with slow pain, which is felt in skin or in the deeper tissues. Then again, the fast pain detected by myelinated A fiber and the perception occur rapidly, and the stimulus core sharp, bright, localized pain not felt in deeper tissues. A slow pain detected by unmyelinated C fibers, small diameters than the A delta fiber. Perception is slow and gradual, not sharp, not fast. Cause dull, intense, diffuse, unpleasant pain. But the fast pain is a sharp, localized pain. But the slow pain is dull, intense, and diffuse, unpleasant pain sensation. And this is table demonstrates the difference between fast pain and slow pain, and this table is very important to memorize. Very important to memorize. We firstly compare between fast and slow pain in perception and localization and the quality of pain and the feeling of pain, causing of pain, stimulus of pain, what is the afferent nerve which transmits this pain, and the final carrying tract which transmits the pain. Firstly, perception. The fast pain is perceived within about 0.1 second after painful stimulus, felt within about 0.1 second after a painful stimulus. Fast pain, fastly localized pain, and this is felt within about 0.1 second. But the slow pain begin after 1 second and more, and then increases slowly over many seconds or minutes. Again, this fast pain is felt shortly after injury, and slow pain is sensed after a long time than the fast pain. This is 0.1 second, and this is a 1 second or more. The localization of the fast pain is bright, sharp, localized sensation. We can localize the pain by my finger, our finger. We localize the pain as a sharp and bright or localized sensation. A slow pain, dull, intense, diffuse, or unpleasant feeling. Dull, intense, diffuse. We can't localize the pain. When we ask the patient which part you felt the pain, the patient answers that I can't localize the pain. The pain is diffuse in my leg, in all back, in all abdomen. And the quality: sharp pain, breaking pain, acute pain, and electric pain. Sharp, breaking, acute, electric pain. This is all forms of pain are bright, sharp, localized. But the slow pain, slow burning pain, aching pain, throbbing pain, nauseous pain, as in case of vomiting, and chronic pain. Okay, in case of claudication pain. Claudication pain means that the muscular pain but diffuse pain. I can localize the muscles which is affected, and I can localize the site of pain. Okay, feeling felt mainly in skin, not felt in most deeper tissue of the body. But the fast pain are felt in skin and also in almost deep tissue or organ, mainly in the deep tissue, not in the skin. And we felt the slow pain in the skin after we felt the fast pain. Any injury in the skin, firstly causing fast pain and then converted into slow pain. The causes of fast pain is pinprick pain, cutting, burning of the skin. But the slow pain associated with tissue destruction or deeper tissue destruction. The stimulus of the pain in the fast pain by mechanical or thermal stimuli, but in slow pain caused mainly by chemical stimuli, not by mechanical or thermal stimuli. And the afferent nerve fiber in the fast pain transmitted by A delta fiber. A delta fiber have a large diameter and the velocity of the transmission of sensation is fast, about 6 to 30 milli in 1 second, which release glutamate as a neurotransmitter. But the slow pain transmitted by C fiber which have a small diameter than A delta fiber and is non-myelinated, but the A delta fiber are myelinated, and the velocity of transmission is about 0.5 to 2 milli in the 1 second, and the chemical transmitter which released in the afferent fiber are substance P. We may make a table of difference between A delta fiber and C fiber. We state that A delta fiber is myelinated but C fiber unmyelinated. A delta fiber small, large diameter, C fiber small diameter. A delta fiber has a fast velocity, C fiber a slowest velocity, and A delta fiber release glutamate and C fiber release substance B. And the carrying tract in spinothalamic tract and in slow pain spinothalamic tract, and we will discuss this tract in details in the coming lectures, Physiology of Pain 2, inshallah. This is the table for the difference between fast and slow pain, and this table is very important to memorize. Okay. What is the receptor of pain? Receptor of pain is a type of free nerve ending. This is a free nerve ending. This is a receptor of pain. This is the only form of the receptor of pain. Free nerve ending that is found in various parts of the body, including skin and mucous membrane, skeletal muscle, blood vessels, and visceral organ. This is a pain receptor. The only type of pain receptor is a free nerve ending. Location of free nerve ending: skin, mucous membrane, skeletal muscle, blood vessels, visceral organs. These receptors are responsible for transmitting information about mechanical, chemical, thermal stimuli that cause the pain. Information about thermal, mechanical, chemical, any kind of stimuli. Non-adapting in nature. What is meant by adapting or adaptation of pain or adaptation of sensation? Adaptation of sensation is acclimatization with this sensation. As touching sensation, we adapt on the touching sensation, as when we wear jacket or we wear a sweat or we wear any clothes, we adapt of this sensation, but the pain is non-adapting in nature, and this is a have many benefit. When the pain is adapting, is very harmful to the body, but the pain non-adapting is to seek the treatment and to run away from the site of injury. So the pain is non-adapting in nature. This is a very important information. Categories of pain receptors. There are 3 categories of pain receptors or nociceptors. Maybe mechanical nociceptors, thermal nociceptors, or polymodal in nature. Mechanical nociceptors respond to mechanical damage. Mechanical damage as a crushing injury, as a trauma, as anything, such as cutting, crushing, pinching. This is a form of stimulus that cause stimulation of mechanical nociceptor. But the thermal nociceptor respond to extreme temperature, especially extreme heat or extreme cold. Extreme heat causing a pain sensation, and extreme cold causing a pain sensation also. The third type is the polymodal nociceptors, respond equally to all kind of damaging stimuli. All kind of damaging stimuli, including irritating chemicals released from injured tissue. irritating chemicals. This is the chemical nociceptors, and any type of stimulation can sensed by this nociceptors, which is a polymodal in nature. Because of their value to survival, nociceptors don't adapt to sustained or repetitive stimuli. Don't adapt, as we will discuss before, don't adapt. Because the pain, when adapted, these are harmful of the body. When the pain is adapted, and the pain must be not adapted to seek the treatment or to run away from any noxious stimulus. And this is the last slide today, and we pray to Allah that you are kindly understand this lectures. Wassalamu alaikum wa rahmatullahi wa barakatuh.